This looks weird, right? How do we go about this? First, I want you to see the parallels between this and this, right? It might be easier if I put a 1 there, okay? I just want you to look at that, store it in the back of your mind, and now let's follow the instructions they're giving us, okay? Express this as this. So clearly the a that they're designating to us is this x plus 3x squared business, okay? So if I take that, I can expand it. I can even use this notation that I've just developed, okay? That's going to be equal to, let's write it out in a few steps. There's the x plus 3x squared. It's all to the power of 6, okay? So I'm going to need the next line. I'm going to need as much width as I can. I'm going to use my NCR notation, right? So I'm going to have NC0, right? Plus NC1. Okay, what happens next? Think of my general term. It's this to the power of r, which in this case is just 1. Yep. So that's going to be this. Is that okay? No. See, that's my whole term there. If you like, it's my a. Right? So there's a in there. Okay? I'm just writing the whole thing out. Okay, I'll go over to the next term. That's going to be NC2. And then I'm going to have x plus 3x squared because it matches. Right? And they've said write it out as far as x to the power of 3. So there is the 3. And there's that. Okay, now I'm going to pause for a second. Sorry. Thank you. Okay, now before we go on, why on earth would they ask you to just stop? Because it's not actually equal to that, right? This is not true, right? This is something else. I can't say it equals, right? But I can say something. I'll work out what to put here in a second, okay? It's not equal because I'm missing the to the power 4 and the power 5 and the power 6. So there are some terms over here that the textbook is just telling me, don't worry about them.
You don't need
it's
them.
fine. Now the question is, why don't I need them?
Because you've got x to the power 6 right there.
No, because symmetry.
Well, there's a couple of reasons. Number one, there's some symmetry, okay? But, well, that could be a problem for me, right? Like if I just take any old terms, okay? If I went to this, right? And if I just pick some arbitrary, okay, just take the first half, because that's what up to the power of 3. Just take those, right? And just don't worry about those. Don't worry about it. It's okay, right? This is a major problem for us. This is not true, right? Have a look at this guy. 1 plus pi to the power of 3. Okay, what is this? This is like 4 point something. 4.1, 4, 1, 5, etc. to the power of 3. So it's something above 64, because that's 4 cubed, right? So 64, 65-ish, right? Well, if you just rub off these terms, it's not 65. It's not even close, right? So on what grounds could I or the textbook just say, just don't worry about those. Okay. Well, I'll show you. Okay. Let me come back to this, right? And what its connection is to this weird number, right? Can you see there's a 1 and a 1 and a 3? Like there's a 1 and a 3, right? So, just like I did over here, right? The difference between this and this is that this is this when x has assumed a certain value, right? Just like this is this when x has assumed a certain value. So then the question becomes, well, what value of x should I choose? And you might be able to even see it there, right? The value of x I want is going to be something that gives me 1 plus 0.01, right? Plus 0.003, which of course I could just write as 1 plus 0.01 plus 3 times 0.01 squared.
So it's not
Okay.
zeros.
Whoops, sorry.
0.0003.
There? Is that better?
And 0.1001.
Hold on.
No, that's right. The top notation.
Yeah, that's all good. Yeah.
Because if you square
If you
it,
square
you
it,
Yeah.
get to.
Yeah, that's right. It's 1% of 1%, which is, 0.0001%. Okay. All right, so I've chosen a value of x, just like I chose a value of x over here. This is a bit weird for us. We're not used to, you choose your own adventure. Pick whatever value of x you want, okay? But you can see why it's going to be useful to us. And now you can see why I can just start ignoring values. Can you see why? Okay. What is x? X is 0.01. So as I go off in this direction, think about what these numbers are actually starting to equal now, okay? So let's have a look at this one. I know what, sorry, it shouldn't be an n, it should be a 6. Shouldn't it? Because that's what n is. It should say 6, that should say 6. And there's my last one, okay? So we stated before that anything C0 is going to be 1, right? The next one along, because it's the 6th row, is going to be 6, okay? And then I've got, now, what is this thing? What is this thing? It's 0.0103, full stop, right? Then you've got this guy, 6C2. Okay, what's the next term along? Is it 15? Is it 15? Let's just double check. I'll go 6C2. Yeah, my memory's not that bad. Okay, 15 is the next term. 15, and then I'll have 0.0103 squared.
Oh, I get what
You can see what's happening now. As I go this way, right, what's going to happen to 0.0103 to the power of 4, to the power of 5, to the power of 6? It's going to be this tiny, insignificant thing, right? And so that's why I can say, well, if you drop off those terms, that's okay. You'll still roughly be equal, okay? Because what I'm dropping off are these trivial terms, okay? So that's why I can stop. So I'm approximately equal to, this is going to be an approximation. I need my last term here. 6C3, what is it? Is it 20? No, it's bigger. What is it? 6C3.
20.
Is it 20? It is 20.
Yeah.
Cool. There you go, 20, 0.0103 cubed. Okay, and then I stop there. And that you can evaluate.
1 point.
Okay, so what are we getting?
1.0634. So 4 decimals.
Thank you.
I finally get what the question was asking.
Yeah, so you see how there's a lot of layers to this.